Okay, good evening everyone. Today we are going to learn a new topic, heat. We skip the topic of we call gravity, skip the topic level. Then we do the topic number 4, heat topic. Okay, heat topic. Okay, heat. Heat. First of all, thermal equilibrium. Thermal equilibrium. Thermal equilibrium. What is the meaning of thermal equilibrium? The definition of thermal equilibrium. Okay, thermal equilibrium is net rate of heat transfer. Net rate of heat transfer between objects in thermal contact is zero. That's called heat. Okay, net. The word net must be there. So net rate heat transfer. Net rate of heat transfer between objects in thermal contact is zero. Okay, what is the meaning of this? Okay, I will explain this one to you. Okay, and for example, these two objects. This is 30 degrees Celsius, 30 degrees Celsius, 70 degrees Celsius, object A and object B. So the heat will be transferred. The heat will be transferred from the high temperature object to the lower temperature object. From the higher temperature object to the lower temperature object, the heat will be transferred. Until one extent, the heat will be, okay, this one. Okay, for example, 40 degrees Celsius, object A, object B, 40. For example, it's not 30 plus 30 plus 70 is 100, average 50. Not necessarily 50. Can be 30, can be 50 also, can be 40, 45, can any temperature must be equal. Okay, the heat transfer from the higher temperature to lower temperature until the temperature of the both object will be same. This is called thermal contact. Can be the object can be solid and liquid, can be any form. Okay, so the heat will be transferred until the object with both object with the same temperature. Until okay, for example, the same temperature, for example, then the heat will be transferred A to B, B to A to B, let's say 500 joule. A to B 500 joule. B to A also 500 joule. So the net heat transfer, A to B 500 joule, B to A 500 joule, net heat. So the heat transfer between two objects must be zero. So net heat, Haber-Bosch. So is 500 joule minus 500 joule. So is zero. So this is called thermal equilibrium. In thermal equilibrium, both objects will have the same temperature. Both objects can be three objects also. Regardless of objects. Not necessarily two objects. Can be three objects and two objects. Okay. But the thermal equilibrium means the temperature. For example, today two objects. Temperature of the both objects will be equal. Temperature of the both objects will be equal. Okay, and based on the thermal equilibrium, temperature equal so the net rate heat transfer between objects in thermal contact is zero. So is 500, for example, 500 joule. B give the 500 joule to A. So is a net Haber-Bosch. okay, minus, so 0. So this is called thermal equilibrium. Thermal equilibrium. Okay. Next one, we are going to learn thermometer. We are going to learn thermometer. Okay, we learn thermometer. Thermometer. Okay. The thermometer, okay, use based on thermal equilibrium. For example, you put thermometer into the mouth, okay, and temperature, the temperature of the thermometer will rise up until the same body temperature, and the temperature will stay. So temperature thermometer and the temperature of the body will be same, achieve thermal equilibrium. Then we take the temperature, we read the temperature from thermometer. Okay, and thermometer and thermometer, we call it thermometer. Okay, and I will teach about thermometer more detail about next week. But today we are going to learn calibrate thermometer. We are going to calibrate, how to calibrate thermometer. How to calibrate? Calibrate thermometer means make a scale. For example, empty thermometer. We give empty thermometer. There is no scales. How to calibrate? Okay. For example, this one. We put it in ice cubes. Okay. This one ice cubes and ice cubes and ice cube we put in the thermometer. This anti thermometer we put in thermometer in ice cube. Ice cube, the temperature must be 0. Ice cube temperature must be 0, so we mark 0 point. And at the same time we are going to learn round bottom flask. This is boiling water. Okay. Heat. Okay, the water boils. Water boils. We make the same thermometer. The thermometer we mark 0 point. We take the same thermometer. We put it in the thermometer into the this one 0 point. 0 point. And the thermometer we put in the boiling water. Boiling water. And the thermometer will rise up, the temperature will rise up. Okay, this one is temperature rise up. This one temperature rise up. What is the boiling temperature? Is 100 degrees Celsius. 100 degrees Celsius. So this one. So okay. Now the same thermometer. The thermometer, the same thermometer, one thermometer, we put it in the ice tubes, and the temperature, we mark the temperature 0 degrees Celsius. We mark the line we mark in the thermometer, we mark the line 0 degrees Celsius. The thermometer, same thermometer, we put it into the boiling water, the round bottom flask. Okay, the boiling water. Okay, the temperature rise up, or the thermometer temperature rise up, or thermometer mercury rise up to 100 degrees Celsius. So you mark 100 degrees Celsius. Okay. Now we are going to learn. How to calibrate thermometer. Okay. Now we are going to learn this one. this thermometer. This thermometer just now we marked 0 degrees Celsius, 0 degrees Celsius, and mark 100 degrees Celsius, 100 degrees Celsius. So the thermometer we mark 0 line at ice, in ice, and 100 degrees Celsius when the boiling temperature, when the water boils, and 100 degrees. So in between empty. How to calibrate means how to make the scales, how to make scales. So we make a thermometer, we measure the length. For example, we measure the length between 100 and 0, 20 centimeter. 20 centimeter. Okay, 20 centimeter. 20 centimeter represent 100 minus 0. 100 minus 0. Okay, it's about 100 degrees Celsius. So 100 degrees Celsius. 100, so 20 cm. So measure the length. So take the ruler and then measure the length between 0 and 100. For example, 20 cm. 20 cm. 20 cm is 100 degrees Celsius. 1 cm equals to 100 degrees Celsius divided by 20. So this one divided by 20, 5 degrees Celsius. Okay, 0 cut 5 degrees Celsius. So okay, so 1 cm is equals to 5 degrees Celsius. So we have to make, okay, we make this one measure 1 cm, we measure 1 cm. Measure 1 cm is 5 degrees Celsius. 2 cm, we measure 2 cm, 10 degrees Celsius. Another 5 cm, another 1 cm. So this box is 1 cm, 1 cm, 1 cm. So it's 15 degrees Celsius. So that's how we have to calibrate. We have to calibrate like this. So we calibrate. We put scales. So 0 degrees Celsius to 100 degrees Celsius. So every 1 cm, this is 1 cm, this is 1 cm. 1 cm, this is 1 cm. The 1 cm, 1 cm, 1 cm, 1 cm, 1 cm. So we got 100 degrees. So you can take 0.5 cm. 0.5 cm is 2.5 degrees Celsius. Like we make a smaller scale. So 0.5 cm, every 0.5 cm, 2.5. Another 0.5 cm, 1 cm is 0.5 is 5 degree. 0.5 cm is 2.5 degrees Celsius. 1 cm is 5 degrees Celsius. 1.5 cm is 7.5 degrees Celsius. So that's how we put a scale. Depend. We can put 1 cm is equal to 5 degrees Celsius, or every 0.5 cm is 2.5 degrees Celsius. We put scale. Every 0.5 cm, 0.5 cm, 0.5 cm, 0.5 cm. So we put scale. So this is how we have to measure. We have to calibrate thermometer. Okay, and okay. Now we are going to do a question. Okay, we are going to do the question. So question one. Okay, question 1, and okay. When the thermometer is placed in liquid X, okay, when the thermometer is placed in liquid X, the length of mercury column is 7.5 cm. Find the temperature of the the liquid. Okay. When the thermometer is placed in liquid X, the length of mercury column is 7.5 cm. Find the temperature of the liquid. So the 7.5 cm. For example, they put a liquid. Here they put liquid. This is liquid X lah. Liquid X. So they put liquid X, for example, and the mercury rise up. Mercury rise up. Mercury rise up. Okay, the mercury rise up. Mercury column is start from 0 lah. Mercury column start from 0 is mercury column 7.5 cm. 7.5 cm. So the mercury column is 7.5 cm. 7.5 cm. The mercury column. So what is the temperature? So we have to do the, for example, 20 cm. For 20 cm, 0 to 100. 20 cm, the difference is 100 degrees Celsius lah. For 20 cm, there's a formula in the book lah, but I don't prefer the formula. I prefer this way lah, manual way. So 20 cm, 100 minus 0. So for 20 cm is 100 degrees Celsius. For 1 cm is 100 divided by 20. So and for 7.5 cm, for 7.5 cm is 100 divided by 20 times by 7.5 cm. So this equals to 37.5. So 37.5 degrees Celsius. This is the liquid X temperature. The temperature of liquid X is 37.5 degree Celsius. 37.5 lah. So 7.5 cm. Okay. For 1 cm is 100 degrees Celsius divided by 20. For 20 cm. For 1 cm is how many degrees Celsius? 5 cm is equals to 5 degrees Celsius lah. That's why we solved the question. So for 7.5 cm, so 100 divided by 20 times 7.5 is 37.5. So the temperature of the liquid is 37.5 degrees Celsius. So I'll give a homework for you. Question 2. I'll give a homework for you. And okay. If the second question, okay, if the length of mercury column is 18 cm, find the temperature of the liquid. Okay. Okay, this one is okay, this is a negative 5 degrees Celsius, negative 5 degrees Celsius, so negative 5. So the length of the mercury column from negative 5 degrees Celsius to 100 degrees Celsius is 25 cm. Okay, from 100 degrees Celsius, negative 5 degrees Celsius to 100 degrees Celsius is 25 cm. So we have to find if the length of the mercury column is 80 cm, find the temperature of the liquid. This is question A. Question A. Question B. If the temperature is 70 degrees Celsius, 70 degree Celsius, okay, if a temperature of 60 degrees Celsius, okay, 60 degrees Celsius, find the length of the mercury column. Okay, this question A and B. Question 2, based on 100 to negative 5 is 25 cm. Difference is 25 cm. If the length of the mercury column is 18 cm, if the length of the mercury column is 18 cm, find the temperature of the liquid. Find the temperature of the liquid. Second question, if the temperature is 60 degrees Celsius, 60 degrees Celsius, find the length of mercury column. Find the length of mercury column. This is question number 2. Question 2, number 2, you must do as homework lah. So it's 100 and negative 5. The difference is not 0 to 100 is 20 cm. It's a different question. 100 to negative 5 is 25 cm. The length, total length is 25 cm. Okay, and we have to do the questions lah. Okay, and we are going to learn today. We are going to learn something like again thermometer. We're going to learn thermometer. We're going to learn thermometer. How to we call it. How to increase sensitivity of thermometer. How to increase the sensitivity of thermometer. So how to increase sensitivity? So how sensitive thermometer or make it. How to make the sensitivity? How to increase sensitivity of thermometer? First one, use a smaller bulb. Smaller bulb. Number 2, use thinner capillary tube, capillary column, capillary tube. Use thinner capillary. Use thinner capillary tube. Okay. Use smaller bulb. This is a big bulb. So the smaller bulb, that is just smaller bulb. So it's full of mercury. Okay. This is a smaller bulb. It's a big bulb. So big bulb, there's a gap. So the temperature. The heat must come to here, and the heat must travel all along the tube, glass tube or the thick glass tube, and reach the mercury storage of mercury. So it is a take time. So its sensitivity is a bit longer lah. Take a longer time. So if a smaller bulb, the heat can be transferred to the mercury column immediately. The smaller bulb, the mercury receive the heat immediately, or we can call it the sensitivity increase. So the heat can be transferred immediately or transferred quickly to the mercury column. Okay. Then use a smaller, we call thinner capillary tube. So this is a thick capillary tube. You must use thin capillary tube. This capillary tube. The thinner capillary tube is mercury rises faster and go down quickly also. Can rise up faster and go down quickly also. So it must use sensitivity. So you must use a thinner capillary tube. Use a smaller bulb, use a thinner capillary tube. So another question, why they use mercury in the thermometer? Why don't you use other liquid? Okay, there's a 4 or 5 reasons. Okay, first reason is a contracts and expands. So expand and contracts uniformly. The mercury contracts, expand and contracts uniformly. That's the first reason. Second reason, I think so. The mercury is having a low melting point. Mercury having low melting point because mercury is only metal in the liquid form. Only metal in the liquid form in the room temperature. At room temperature 25 degrees Celsius. At room temperature is 25 degrees Celsius. So, okay, second reason is having low, low melting point. Third reason, it doesn't stick to the glass wall. So the mercury can rise up and can go down. Okay, so it doesn't stick to the glass wall. Or doesn't stick to the capillary tube. Doesn't stick. The mercury doesn't stick. Okay, and the fourth reason, it is opaque. Opaque means it's not. It's something like it's not transparent. Can be seen from outside. The mercury rise up and coming down. Okay, and this is the question I gave you. But I'll try to give some other questions. And today lesson we're going to learn today only this one. We're going to learn next week or next class. Okay, we're going to learn specific heat capacity and so on. Okay, thank you very much. Okay.